Okay, here we go with question 11. There's a whole bunch of things going on here. We've got TA is a tangent, and I can tell by looking at the picture, well, those are two radiuses. They've told us here, I bet you, that PM equals PT. They've told us that TA is perpendicular. That's why there's a little 90 degrees right there. And, well, we've got that radii. We kind of know that's an angle at the center. Don't be fooled. This isn't a cyclic quad, but there's some tan chord things going on here for sure. Okay, let's see how I did this many months ago. I'm going to try and prove that MTAR, that's a cyclic quad. Oh, that's a line from the center. And this here, oh, I know about that. I know that a line from the center that bisects a chord must be perpendicular. And there's a special thing for that. I know that M1 is 90 degrees because a line from the center to the midpoint is a line from the center to a bisected chord makes it 90 degrees. Well, if M1 is 90 degrees and this A1 is 90 degrees, MTAR has to be a cyclic quad because the converse of the exterior angle of a cyclic quad. There we go. Hey, A wasn't too hard. Let's try the next one. That PR equals RT. PR equals RT, that these two are equal. Well, that would mean that T1 has to equal P somehow. Well, that might take, let's see what I did. I went that M2 is equal to 90 degrees because of angles in a straight line. It's given that these two things are equal. That's true. And MR is common. Oh, it looks like I'm using side angle side to show that PR equals RT. PR here has to equal RT because we have this side is given, this angle is given, this side is common. These two triangles are congruent. They're the same in every way, which makes PR equal RT because they're congruent triangles. Okay, well, that was okay. Maybe there's another way to do it. That's the way I did it. Let's see. TR bisects PTA. TR bisects PTA. That, in other ways, they're saying, prove that T1 equals T2. Let's see how I did it. I wonder how I did it. Well, I've got I bet you there's a tan chord in there, T2 equaling O1. I don't know. Let's see. P2 equals angle P. It is a tan chord thing there. But T1 is equal to angle P because we know these sides are the same, right? So therefore the angles are the same. Well, if that's true, then T1 equals T2, and that's what we were supposed to prove, that TR cuts them into two equal pieces, bisects them. Okay, now we're supposed to prove that T2 is half of O1. Let's see how I did it. Well, we know that T1 is equal to T2. We've already proven that. We know that T1 is equal to P. It's been proven. Well, that means, oh, and we know that P is equal to half of O1. But because, therefore, T2 must equal P. It must be the same. It must be equal to half of O1. Why does P have to be half as big as O1? That's the angle at the center is 2 times the angle at the circumference. And right here, we've got that P is equal to T2. So then T2 must equal 1/2 times O1 as well, because they're both equal to each other there. So there we go. There's question 11.